Today, our main focus was ratio tables, and I'm going to walk you through the central example that we used in class, and then below this video, there are directions on which assignments you need to make up if you weren't here. So for today's Do Now, I asked students to take a look at the pattern in this picture. You could think of it as 3 separate pictures: image 1, image 2, and image 3. What most students noticed is that the green boxes are growing by 3, and the blue boxes are growing by 4s. Now, we could organize this pattern into what's called a ratio table, and I think it'll look somewhat familiar to you. If I create one column for green and one column for blue, I can describe the relationship between the green and blue boxes. So I know that for 3 green boxes, there are 4 blue boxes. And I can do the same thing for 6 green boxes and 9 green boxes, which I'll fill in my table here. So these are all ratios. The ratio of green to blue is 3 to 4. It's also 6 to 8, and it's also 9 to 12. We can see that our ratio table is growing by 3s. Each time we move forward, we add 3. And by 4s. Each time we move forward in the blue column, we add 4. We can also see that these ratios are equivalent ratios. So instead of using addition, we could demonstrate these ratios' equivalence using multiplication. 3 times 2 is 6, and 4 times 2 is 8. 3 to 4 is also equivalent to 9 to 12 because I could multiply both sides times 3. And 6 to 8 is also equivalent to 9 to 12 because 6 times 1.5 is 9, and 8 times 1.5 is 12. What's important for you to realize is that ratio tables are simply a collection of equivalent ratios. That means that every single ratio you put in a ratio table must be equivalent. And remember, we know ratios are equivalent when we can multiply both sides by the same number to create the second ratio. This must be true for every single entry in a ratio table. Now, ratio tables are pretty similar to another tool we have, which is the double number line. Now, of course, a double number line looks like this. If I have blue and green, I would be counting by 4s and by 3s. Now, the key rule of the double number line is that we always need to count by the same amount. You might remember us talking about how you can't skip. If you're adding 4, you're always adding 4. It would be wrong for me to put, let's say, 50 here, because I'm not counting by 4. That's a huge no-no. It would need to be 16. However, it's a little bit different in a ratio table. For example, if I put 30 here, obviously I'm not adding 3. It's not plus 3. It's not what I'm doing. However, the number 30 could still be a valid entry as long as whatever I put here creates an equivalent ratio. So let's say I want to use the ratio 3 to 4 as my known to figure out what goes in the blank. Well, I know that 3 times 10 is 30. And again, whatever ratio I end up with has to be equivalent. So if I multiply 3 times 10 to get 30, 4 times 10 gets me 40, and 40 is my missing number. That makes this a valid entry as long as it is an equivalent ratio. In other words, we do not need to skip count in ratio tables as long as our entries are all equivalent to each other.